Hello, brilliant minds. You're welcome to another class with Mr. Olukorede. Now, let's solve this problem. We have to find x if 2 raised to the power of x plus 2 raised to the power of x plus 1 down to 2 raised to the power of x plus 10 equals to 4094. So how do you do this? Now, I must remember this rule. Whenever you have x raised to the power of m plus n, the result is x raised to the power of m times x raised to the power of n. Okay, so now this equation turns to 2 raised to the power of x plus. I'm going to apply this rule on this 2 raised to the power of x plus 1. So we have 2 raised to the power of x times 2 raised to the power of 1. So if you compare this with this, now your m is x while your n is 1. So I've expressed this such that it looks like this. Can you see that? All right, so the same thing also applies to the next one. We have 2 raised to the power of x times 2 raised to the power of 2. Okay, so on until we get to 2 raised to the power of x times 2 raised to the power of 10 equals to 4094. Okay, so now let's look at the left hand side. We'll find the greatest common divisor, the GCD. All right, so the GCD is 2 raised to the power of x. So let's bring that out. Okay, so we have 1 plus 2 raised to the power of 1, okay, plus 2 raised to the power of 2, and so on, down until we have 2 raised to the power of 10, and that is equals to 4094. Okay, now let's look at what we have in the bracket here. Now, it's a sequence of numbers, okay, and when you look at it, we see that it's a geometrical progression. So 2 divided by 1 is the same thing as 2 raised to the power of 2 divided by 2. Now the next one is going to be 2 raised to the power of 3. Okay, so that means it's a geometrical progression. So we're going to be making use of this formula to add everything together. All right, so we have we're going to be making use of Sn equals to a bracket r raised to the power of n minus 1 over r minus 1. Okay, so that's what we're going to be making use of. All right, so now we have Sn. What is n? The number of terms we have here is what? Is 11. Okay, because when you look at this is the same thing as 2 raised to the power of 0. 1 is the same thing as 2 raised to the power of 0. So there's a count from 0, 1, 0, 1, 2, down until we get to 10. And that's 11. All right. So that means we want to find the first 11 terms. So equals to, now the first term is 1. So we have 1 times, now what is the ratio? Now the ratio is 2 raised to the power of 1 divided by 1. That's same thing as 2. Okay, so now we have 2 raised to the power of 11 because n is 11. All right, minus 1, everything over 2 minus 1. R is 2. So we have 2 minus 1. Okay, so we have S11 is now that's 2 raised to the power of 11 minus 1, everything over 1, and S11 equals to 2048 minus 1. So that's what we have. Now 2 raised to the power of 11 is 2048 minus 1. All right, so we have S11 equals to 2047. Okay, so now let us come here. So that means everything we have here is the same thing as 2047. So we have 2 raised to the power of x times 2047 equals to this. That is 4094. So here you can divide both sides by 2047. So we have 2 raised to the power of x equals to 4094 divided by 2047. So we have 2 raised to the power of x equals to that's 2. Okay, so 2 is the same thing as 2 raised to the power of 1. So therefore x equals to 1. So, and that is the answer to the problem. All right, I hope you've learned 1 or 2 things. If you love to join our online classes, so you can connect with this number +234 8039 179465. All right, thank you so much for watching.